Hello everyone, I am Sheela C S. I am pursuing Ph.D. under the supervision of Professor Kuri, Network Research Lab, Department of Electronic Systems Engineering, Indian Institute of Science, Bangalore, India. I received MTech degree from the Department of Electronics and Electrical Engineering, IIT Kharagpur in 2012. Before joining IISc for the Ph.D. program, I have worked as an assistant professor in the Department of ECE, Harvey College of Engineering, Bangalore from 2012 to 2018. Teaching has always been a wonderful experience to me. I'm very excited to tell you all that I'm offering a course on experimentation with WLAN Toolbox of MathWorks. This course is for students or researchers who wants to learn and explore MATLAB WLAN Toolbox, who wants to know with the WLAN technology, specifically IEEE 802.11ax, who loves coding and to explore more with the WLAN Toolbox. The course contains about 8 simulation experiments which emerged during my initial research on IEEE 802.11ax. Each experiment contains a learning objective, the explanation of the necessary technical concept, detailed explanation of the MATLAB code, and the discussion of simulation results. The objective of this course, as I told you earlier, this is for students and research community who wants to learn MATLAB WLAN Toolbox or WLAN technology. This course helps the students to start using the WLAN Toolbox with much ease. Coming to the prerequisite, the learners are expected to have some basic knowledge on digital communication, wireless communication, WLAN standards, and probability and random processes. Coming to the course content, the first topic is the discussion topic on Introduction to WLAN Toolbox of MathWorks, wherein I discuss various helper functions which is being used and various functionalities of the WLAN Toolbox which is required to build end-to-end link level simulation. Experiment 1 is on IEEE 802.11ax channel model. Here we discuss various delay profile, the channel impulse response of various delay profile model, the path loss model, and the statistical distribution of the channel amplitude or the channel envelope. Here we dig deeper in order to understand the difference between the different channel fading models such as Rayleigh, Raytheon, Nakagami, etc. The experiment 2 is on channel frequency response of indoor channel models. The channel model B is a typical residential scenario. Channel model D is a typical office enterprise, and channel model E is the outdoor large office. Here we see what is the channel frequency response across subcarriers and obtain a statistical distribution of the channel gains. Experiment 3 is on IEEE WLAN 802.11ax 5-frame format. Here we discuss the 4 types of PPDU frames which is supported by 11ax and see how legacy part of the preamble is different from the HE, that is high efficiency part of the packet preamble. We plot the LLTF field or know more about the structure of the LLTF. LLTF is a legacy long training field which is basically used in channel estimation. Actually, experiment 4 is on channel estimation. So here we try to understand the different parts of the PPDU frame and more importantly, how the LLTF field would look like. Experiment 4 is on channel estimation in 11ax is OFDM channel. So there is a prerequisite discussion topic on OFDM, orthogonal frequency division multiplexing. I suggest readers to go through the prerequisite discussion videos before a particular experiment. So in experiment 4, we do 2 or 3 different types of channel estimation and we see how compare the channel estimation in each of those types. Next is the discussion topic on rate adaptation in wireless communication. The experiments 5, 6, 7 is based on rate adaptation. So there is a discussion topic before these experiments. So rate adaptation in simple words is a selection of optimal modulation and coding scheme, that is a MCS, based on the varying channel, wireless communication channel. So experiment 5 is a MathWorks example that actually discusses the dynamic rate control simulation in 11AC channel. So it's a closed loop rate adaptation scheme wherein the receiver sends the feedback to the transmitter in order to help the rate selection. So here we discuss the code and also the simulation results on instantaneous BR and throughput, etc. Experiment 6 and 7 is based on the classic implicit feedback algorithm, that is ARF, auto rate fallback, and adaptive ARF, adaptive auto rate fallback. So here these two algorithms basically uses the MAC layer acknowledgement feedback in order to decide the rate. Here we discuss the paper which discusses ARF and ARF in detail, and also see how these algorithms can be implemented, and see the simulation results for 11AX channel. The last experiment is based on HEMU, that is high efficiency multi-user transmit packet power analysis for different modulation and coding scheme combination and RU size. RU is a resource unit. So this experiment helps to understand how to initialize HEMU transmission in 11AX channel. In this experiment, basically we vary the allocation index in order to change the RU size, the number of RUs, etc. RU is a resource unit wherein you group the subcarriers, and you assign a particular user to a particular RU. So basically in this experiment, we analyze the transmit power for different MCS and RU sizes. I thank Center for Network Intelligence, Cisco CSR initiative of Indian Institute of Science for granting the PhD fellowship for the 3 successive years from 2021 to 2024. I also would like to thank MTech CNI scholars Jagadish, Kalyan, Ritik, Manisharan, Venkata Sainath for copying the course material into a Jupyter notebook. This integration actually helps the readers to read the course content within the Jupyter notebook and also the execute the code within the Jupyter notebook. The course content and the the MATLAB code is uploaded on CNI's GitHub repo, WLAN module. The recording for all experiments is available on CNI's YouTube channel. Thank you all and welcome to the course. Happy learning.